In this video, we will discuss a very important concept, the concept of interrupts. And as we will see subsequent videos, that interrupts are very important to have or to fulfill the two motivating factors of operating systems. So, let us see what are interrupts. When you talk to a computing system, you talk through keyboards, mouse, and sometimes by tapping the screen if you have a touch screen. Now, when the CPU is operating, is executing, you have given power to the CPU does not stop. The CPU never sleeps. The CPU is always executing something. Either it is executing your program or some background processes, or if it has nothing to do, it still executes an assembly level instruction called no ops. Basically, it is doing nothing, but still executing some dummy code. Now, when you try to interact with this running CPU, you interact through keyboard, mouse, tapping the screen. All these are events. These are events when the CPU needs to be stopped and you need to redirect the execution of the CPU. Interrupts help us do this. So, let us talk about interrupts. Whenever you get an interrupt or whenever the computing system gets an interrupt, be it mouse click, be it keyboard press, be it touching the screen, there is a interrupt line which is similar to the address data bus, is just a bus. Whenever there is an interrupt, there is a square wave of voltage that is taken at this bus. This bus is called the int x line. So, at the int x line there will be square wave. Now, remember in the first video we talked about program counter, we talked about registers, CPU registers and arithmetic logic unit. The program counter and the status register are two such registers in the CPU. These have very important functionality. The program counter stores the address of the next instruction that you want to execute, whereas status register stores certain important information which we will see in the next slides. Now, whenever you have this square wave in the int x line, the CPU needs to be stopped. So, CPU takes an interrupt. What does the CPU do next? It takes the program counter and pushes it into the stack. Now, what is a stack? This concept you will get in Principles of Programming Language course. A stack is a part of a program where it stores local variables, function frames and a lot of other things. So, it is for this particular video, let us consider the stack is some scratch pad memory where a program can store whatever it wants. Right. So, when a CPU takes interrupt, the first thing it does is that it takes the program counter and pushes it into a stack. Then it searches for something called an interrupt vector or IV. What is this interrupt vector? Now, remember, whenever you take an interrupt, the main purpose of taking an interrupt is to redirect the execution of the CPU. So, what does redirection of execution of CPU mean? That means you are trying to run a different program. So, if you are trying to run a different program, then that program has to be in memory, in somewhere in memory. So, it has to have an address. The interrupt vector stores the address to that particular program that you will run when you take an interrupt. And the program that you run when you take an interrupt is called the interrupt service routine. Or ISR. It is also called interrupt handler. So, now With respect to every interrupt, there is a table in the operating system. What is this table? Each interrupt has a number. Each number has a corresponding interrupt vector or IV. In the table in operating system, there is a listing of this interrupt number and the IV. So, by taking a look at this number, an operating system can figure out what is the interrupt vector related to that particular interrupt. And this interrupt vector has the address to the interrupt service routine or interrupt handler. Now, once you have the address, that interrupt vector is loaded into program counter. Now, remember, program counter has the address of the next line of code that you will run. So, if you load the address of the interrupt vector into the program counter, then that means the next program that we will run is the interrupt handler or the ISR. So, once you run the ISR executes and then you return. Once the ISR is done executing, you return from the interrupt. So, once you return from the interrupt, then what happens is that you take the stack, you pop the stack and you put it into the program counter. Now, when you pop the stack, remember that before executing the interrupt, we pushed the program counter into the stack. This program counter has the address of the previous program that we are running before you went into the interrupt service routine. So, when you pop the stack and put it into the program counter, this is basically returning to the previous program. Now, this is the mechanism of how a CPU takes interrupt and how the CPU executes interrupt service routine. So, these are the steps of executing an interrupt. So, first what the CPU does is that it pushes the program counter onto the stack. Then we skipped this line, we did not discuss this line, but this line is very important. It pushes the status register into the stack. What is the status register? It will come in subsequent slides, but let us go with the flow. It pushes the program counter into the stack first, then it pushes the status register onto the stack, then it loads the program counter from the interrupt vector. It also loads the status register from the interrupt vector. So, from these two lines, you know that the interrupt vector not only has the address of the ISR, but it also has the status register. The status register is very important. Then once the interrupt service routine is done, you return from the interrupt. Typically, the assembly level code that you use to return from the interrupt is RET. RET has a lot of functionalities. We are not going to discuss that in this video. Let us skip this line. Once you return from the interrupt, we pop the stack and put it into the status register, and we pop the stack again and put it into the program counter. Now, notice one thing, we pushed in the order program counter first, then status register, but when we are popping, we pop the status register first and then the program counter. This is because the stack is last in first out, that is why. So, this is the steps, these are the steps that you have to take in order to execute an interrupt. Now, let us get into more details of the status register of an interrupt service routine. So, this is the status register. Status register has a lot of things. It has the stack pointer. It has a lot of other bits, but there is one important bit called the mode bit. We will see that this mode bit helps us in the first motivating factor of operating system. Now, this mode bit can be 0 or 1. 0 corresponds to user, while 1 corresponds to privileged. What is user, what is privileged? We will talk about that in the next set of videos. Now, this arrangement can be different depending upon different operating systems. In the book, this arrangement is reversed. So, that means 1 is for user, 0 is for privileged, but it does not matter for the purpose of this discussion. That is it for this video.